Okay, so we've been talking about sequences and explicit formulas where they give us a formula and we're able to put in the value of n and find, a term or several terms. Sometimes we find the first 4 terms or first 5 terms or something like that. But with explicit formulas, you could find, just one term. They could say, here's the formula, the explicit formula, find the 10th term. Okay, so that's what we've been working with. Now we're going to talk about something else. And to introduce this, I'm going to talk about what's called a Fibonacci sequence. So Fibonacci, I believe he was Italian, an Italian mathematician, and the sequence is named after him. And the sequence goes like this: 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and I could keep going, and I don't have this on a piece of paper or anything. It's in your book, but I'm able to find the next term because of a certain pattern. Now, if you see the pattern, great, or if you've heard of the Fibonacci sequence, you might already be familiar with this pattern. But this is called a recursive sequence, okay? It's based on a recursive formula. Okay, but what's happening here is, stop the video if you want to figure it out. Stop the video because I'm going to give away the secret here. Okay, so if you stop the video, now you're back. This is how you find the next number. So notice that you have 1 and 1, and that's 2. And then 1 and 2 make 3. And then 2 and 3 make 5. So what we're doing is we're taking the previous 2 terms, adding them together to get the next term. So 1 and 2 make 3, 2 and 3 make 5, 3 and 5 make 8. So if I were to go down here, I could say the next term is going to be 89, right? Because 34 plus 55 is 89. Okay, and so this is an example of a recursive formula. The sequence, the term, is based on previous terms. So there's no way for me to just say, hey, let me find the 100th term of the Fibonacci sequence without finding the 99 terms ahead of that. That would be, difficult to do. It would take me a long time. Okay, so that's the difference between a recursive formula and an explicit formula. A recursive formula, it's based on previous terms in the sequence. They usually give you the first term. They have to give you something. They have to start you someplace. They're usually going to give you the first term. And then they'll base the formula on previous terms. So let's say we have this situation. We say the first term is 3. And then here's an example of a recursive formula. A sub n, so the nth term, is equal to 2 times a sub n minus 1 for n greater than or equal to 2. Okay, so if you wanted to find the sequence, you'd start out with the first term, 3. But then to find the second term, you'd have to go a sub 2 equals 2 times a sub 2 minus 1. This is all the subscript, minus 1. Well, what is 2 minus 1? 1, right? 2 times a sub 1, this right here just equals 1, minus 1. But we know a sub 1. That was given to us. So it's 2 times 3 minus 1. 6 minus 1 is 5. Okay, so the next term is 5. Then if you wanted to find the third term, I'm going to run out of room. Okay, if I wanted to find the third term, I'd need 2 times a sub 3 minus 1 minus 1. Well, that's 2 times a sub 2 minus 1. because 3 minus 1 is 2. So now I need the second term that I just found out, 2 times 5 minus 1, or 10 minus 1, which is 9. And then so on and so forth, okay? So that's how you find a recursive sequence. Use the recursive formula. It's based on that subscript, and that's how they're going to write the notation. Okay, so now here's an example. Write the first 5 terms of the sequence defined by the recursive formula. Okay, the first term is 9. Great. To find the second term, I have to find 5 terms. Okay, it's going to be 3 times a sub. Now, it's going to be 2 minus 1. I'll just write it this time, but then on the next one, I'm going to not want to write it. Okay, and we're allowed to use this formula if n is greater than or equal to 2, and we've got n being 2 right now, so it's all good. All right. So a sub 2 is going to equal 3 times a sub 1 minus 20. But we know a sub 1, it's 9. And so 27 minus 20 is just going to be 7. And so a sub 2 is 7. All right, now we want to do a sub 3 because we've got to do 5 terms. So 1, 2, 3. It's going to be 3 times a sub 2, right? Okay, so it's going to be the previous term because it says minus 1. Now, they could say minus 2, but they don't. Okay, it's usually minus 1. All right, now what was a sub 2? 7. Okay, so 21 minus 20, which is 1. But okay, so a sub 3 is equal to 1. A sub 4. Well, that's going to be 3 times a sub 3, I don't know why I put the parentheses in, minus 20. So that's going to be 3 times 1 minus 20, which is going to be 3 minus 20, which is going to be negative 17. All right, so we're almost done. We've got one more. A sub 5 is going to be 3 times a sub 4 minus 20, or 3 times 17 minus 20. I think that's 51 minus 20. Oh, it was a negative 17. Yikes. Negative 51 minus 20. So I'm getting negative 71. Okay, and that was a sub 5. Now, one thing I want to point out, when they ask for the first 5 terms, even though they gave you the first term, they want you to include that. So you would write this as 9, comma 7, comma 1, comma negative 17, comma negative 71. Those would be the first 5 terms in the sequence.